open your books to page 364. We are going to be in lesson 24.3 called Subtracting Polynomials. So we learned how to add them. Now we're going to learn how to subtract. And there's a little bit different rule that we're going to have to focus on today. But our learning target is subtract polynomials algebraically. So if you're looking on that page, it starts out with example A. To subtract a polynomial, you add its opposite or subtract each of its terms. The opposite of a number is its additive inverse. So example A is showing us how to subtract horizontally. And then it says write your answer in standard form. So notice step 1 says distribute the negative. Well, what negative are they talking about? They're talking about this subtraction sign between the polynomials. So what we do is we leave the first polynomial alone exactly how it is. Notice every sign stays the same. I'm just going to bring it down. But distributing the negative means that I'm going to change the sign to every term in my second polynomial. So this negative is distributed to the 5x squared, to the negative 4x, and to the 6. So this positive 5x squared becomes a negative. Negative times negative 4x, this turns into a positive. Negative times positive 6, this turns into a negative. So again, we rewrite the first polynomial and the first set of parentheses exactly how it is. In my second polynomial, I'm distributing the negative. So distribute means to multiply, which changes all of your signs in your second polynomial, the second set of parentheses. Okay? Then, just like when we were learning how to add, we're going to identify our like terms and combine them. So I see a 2x cubed, and I don't have any other cube, so I'm just going to bring that down by itself. So it comes down. Then I'm going to look at the next highest degree, which is my x squared. So 8x squared minus 5x squared. What's 8 minus 5? 3. So 3x squared. So then I'm going to cross those out because I've used this, I've used that, and I've used that. Okay, let's look for the next highest degree, which would just be x's. So I have a 1x plus 4x. 1 plus 4 is 5, and then we've used those, so I'm going to cross them out. And lastly, I look for constant terms, numbers by themselves. So I have a positive 10 minus 6, which gives me 4. Is this in standard form? Yes, because I'm in descending order of degree. So my highest exponent is 3, and then 2, and then 1, and my constant term comes at the end. So this right here is my final answer, and it's written in standard form. Now, at the bottom of that page, further down, it says you could also subtract vertically if you would like to. So what that means is you can line up like terms underneath each other. So we have x cubed, and there's nothing underneath here because I don't have another x cubed to subtract. Okay. And then when you line up your x squareds, your x's, and your constant terms, you can do that way. And notice they still take this negative and distribute it through. And so right here, that changes all of our signs. Okay, so then we get 8 minus 5 is 3. 1 plus 4 is 5. 10 minus 6 is 4. So this will be our final answer. So however you want to do it, if you want to line them up vertically with like terms, if you want to highlight like terms, circle like terms, whatever works best for you. In the My Notes section on that same page, you should have enough room. I want you to write down this example, and we're going to go through this one together. Now, I'm going to leave my first polynomial, and this is a trinomial because there's 3 terms. I'm going to leave it alone. Distribute, distribute. Negative times negative is a positive 2x squared. Negative times positive 3x is a negative 3x. Okay, then I'm going to combine my like terms. So I have 3x squared plus 2x squared, which gives me 5x squared. My next like terms, 5x minus 3x, which is a positive 2x. And then lastly, I have just one constant term, nothing to combine it with, so plus 1. And then this is currently in standard form. My highest exponent is 2 and then 1, and my constant term comes at the end. So this is in standard form. Let's do another example. You can either do this in the My Notes section on 364 or the blank space towards the bottom. So copy this down. I'm going to leave my first trinomial alone. The second one, distribute the negative. So negative times positive is negative 1. This becomes negative 3m to the 4th power. And this becomes a positive 7m squared. Now I'm going to find my like terms. And remember, we want to write this in standard form. So I am going to look for the highest degree or the highest exponent first. So I have negative 4m and negative 3m. And if I wanted to, remember, we could write these vertically underneath if that helps you. And then I see a negative 1 and I see a positive 7m squared. So if I was to do it vertically, it's going to look like this. Okay, so I'm going to ignore everything to the right. So I've lined them up vertically, like terms underneath like terms. So negative 4 minus 3 is negative 7. 12 minus 1. And 2 plus 7 is 9. But is that in standard form? No. So I need to rearrange from biggest exponent to smallest exponent, and then my constant term goes at the end. Now, if I left them horizontally, I could have found the m's to the 4th power first, and then I would have done this m squared second, and then lastly, I would have found my constant terms, my numbers by themselves. So either way works. You choose what method or what system you like the best. All right, on page 365, you're going to see try these A. I want you to do A through D. So pause the video, take the time to subtract all of these polynomials and make sure that your answers are written in standard form. Go ahead. So distribute the negative, and then ignore this because it's gone. And I have 5x minus x, so that's 4x. And then I have a negative 5 minus 7, which is negative 12, and that's in standard form. Distribute the negative, which changes my signs. So then I have 2x squared plus 5x squared is 7x squared. Positive 3x plus 2x. 2 plus 9. And that's in standard form. Change my signs. Take the time to change your signs so you don't make mistakes. And you can also take the time to rewrite this if that helps you. Okay, and then look for your like terms. Or if you wanted to, you could take this and line it up underneath. So you could have your negative 4y squared there and your positive 9 here. And this is in standard form. Oops. It's a Monday, so I made a mistake with a simple addition question. 17, not 15. My mistake. So this becomes a negative, negative, and a positive. So then this is gone. Now, I'm going to make this in standard form right now because I can tell that they're both not in standard form. So let's look for the highest exponent. So positive 14x squared plus 7x squared. I'm going to do that first so I don't have to rearrange it at the end. You can rearrange it at the end if you would like, just don't forget to do it. So then my next highest would be the x's. So 5 minus 8 is negative 3. And then we have a positive 12 minus 15. 12 minus 15 is negative 3. And this is in standard form, descending order, highest exponent to smallest exponent. Jump to page 366. And go ahead and do questions 3, 4, and 5. Again, pause the video and try these questions on your own first before I go through the answers. One x squared plus 4x squared, 2x plus x, 3 minus 5 is negative 2, and this is in standard form. And then I'm going to write this vertically. Some of you like to do it that way, so it becomes a positive y squared, a positive 3y, and a negative 4. So 5 plus 1 is 6. 1 plus 3 is 4. Negative 2 minus 4 is negative 6. And that's my final answer. And lastly, it says Jill used the vertical method to subtract as shown below and identify the error here. So where did we make a mistake? Oops. Her algebra is correct. The addition and subtraction part is correct. But in the very beginning, did Jill distribute the negative? No, not to each term. So this should be negative x squared and a negative 2x and a negative 4. So both of these terms should have been negative. So then it would be 2 minus 4, negative 5 minus 2x, and then the first term was correct. So that should have been the correct answer. Make sure you're distributing the negative to each term and not just the first one, but also to the 2x and the 4.